Yeah. Good afternoon, everyone.
Good
So,
afternoon.
Good afternoon, sir.
Good
yeah,
afternoon.
second session, and we'll be
Good afternoon, sir.
discussing divisibility. Again, this part, at least the basic definition you must have done in schools, but the problems which we'll be doing here, they'll be typical Olympiad style problems. So that will little non-routine. Now, before we start with problems, let's revise basic ideas, basic concepts. Yeah. So very first thing before we start with divisibility. Essentially, we'll be doing with integers. So what are integers? So we work in set of integers. What is set of integers? You can write like yesterday in chat box, or if you want, you can raise your hand and you can answer. What is set of integers? Okay, what is set of natural numbers? Set of naturals. So counting numbers like 1, 2, 3, 4, and so on. They are called as natural numbers. And is 1, 2, 3, 4 along with 0 and even negative numbers. Yes, absolutely. Very good. Yeah. So natural numbers, the counting numbers plus 0 along with negative numbers. So shall I write this way? 0 plus 1 minus 1 plus 2 minus 2 plus 3 minus 3 and so on. This is called a set of integers, right? And as far as notation in higher maths are concerned, naturals are denoted by n, but mathematicians always do little different than the other word. So they show it this way, one extra line. And set of integers is not shown by I, it is shown by Z, and that Z stands for German name Zeilen. Zeilen. It is German name for integers. So generally they'll be denoted, that set is denoted by Z. And as I said, mathematicians always think of themselves little different than the other word. So they put one extra line. It's not the usual Z. Is that fine? So that's the notation. So we'll be working in set of integers. Okay. Yes, Ashmi, that's a rational number here. Very good. So maybe here itself, let me recall. We also further larger set called a set of rationals. And what are rational numbers? They're fractions like 1 by 2, 2 by 3, or even I can have something like 5 by 4 and so on. So you call them accordingly as improper fraction, proper fraction, Egyptian fraction, and so on. So more generally, what is the rational number? So they are numbers of the form a by b, where a, b are integers and b is non-zero. We cannot divide by 0, right? And in these sets, we have mainly two operations like addition and multiplication. And when we talk of integers, there is one extra operation like subtraction, right? And what I mean by operation, so for example, in case of natural numbers, addition of two naturals is again a natural. So suppose if I say 3 plus 5, 3 is natural number, 5 is natural number, 3 plus 5, that is 8, which is again a natural. And as well as their multiplication is a natural number, right? So on these lines, I can't say minus is proper operation on set of naturals, because if I do 3 minus 4, so it's natural minus natural, and answer is not a natural, it's minus 1, which is not a natural. But in case of integers, that is proper operation, right? Well defined. Yeah. So apart from this plus, into, and minus, we'll be talking of one more operation, which is not as such operation on set of integers, but it's well defined on the rationals, and that is divisibility, division. I hope you must have come across this symbol in schools.
Yes, sir.
Yeah. So let me go to next page and we'll just recall basic definition of divisibility with the help of examples. So for example, we are working in set of integers, z, and I'll ask you some questions. Maybe you can write answer in chat box if you want. Does 3 divide 12? What are you say, yes or no? You have to justify why that is so. Does 3 divide 12? Questions are simple. You can answer in chat box.
Yes, sir.
Yeah. So there are many yes here, and there is no single no. Yeah, very good. Some of you have written even the justification. So answer is yes. 3 divides 12, yes. Nobody has said no. And we'll come to the reason why we say 3 divides 12. I'll ask the next question. So now start answering the next question. Does 4 divide 12? But keep in mind, whatever you write, yes or no, you have to justify later on, like why you are saying yes or why you are saying no. Oh, so once again, there are so many yes, and there is no single no. Very good, fine. So let's go to next question. Okay, just a minute, just a minute. Viraj has written answer. Viraj, so you have written 4 divides 12 because if we divide 12 by 4, it leaves no remainder. So what do you mean by divide 12 by 4?
By that I mean if put 12 evenly into four
Very good.
separate areas.
Very good. Yeah. So like for example, you can imagine, say suppose there are 12 students, group of 12 students, right? And if I want to make their groups, so, or let me take it in reverse fashion. Suppose I have say for example, 4 students, and if I have 12 chocolates with me, and if I want to distribute among those 4 students evenly, so I'll keep on giving like this. So 1 chocolate to first, 1 chocolate to second, 1 chocolate to third, 1 chocolate to fourth, and still I have 8 left with me, right? Again, I'll distribute 1. So there should be no quarrel. I have to distribute evenly. These are 8 chocolates, and still I have 4 left with me. I'll again continue. Space there. 1 to second, 1 to third, 1 to fourth. And now there is nothing left with me. So 12 chocolates, when I distribute among 4 students evenly without any quarrel, then I'm left with no number. So if there is no chocolate left and there is no quarrel, which means I have distributed evenly among those 4 people, then answer is yes, right?
Yes, sir.
Yeah. Now one more question. So you can stop answering second question now. Oh, Arav, just a minute. Very good. Arav, very good. So 12 mod 3 is 0. Fine. So do you know mod? Mod function?
Yes, sir.
Yeah, very good. Have you learned it from some book or from some teacher?
Sir, I've read it in a book.
Very good. Yeah. So, in fact, this was a concept given by great mathematician Gauss, Carl Friedrich Gauss. Maybe if you are interested in number theory, so whole this chapter, it comes under what is called as number theory. So if you want to learn basic number theory, a nice book to start with is David Burton. And it contains a lot of stories, history. Even the book is simple. The manner in which he has explained the things, that is accessible to you also. And I hope on internet free PDF is available. So maybe if you are interested, you can go through number theory by David Burton. There you'll see some typical concepts like mod, congruence, etc. Of course, congruence in number theory, not in geometry. Yeah, so let's go ahead with one more question. Does 5 divide 12? Now everyone is saying no. Nobody is saying yes.
Sir, a question.
Yes.
So in this, can we use fractions, not only not only integers and not only integers and natural numbers?
So as far as this divisibility is concerned, we do in integers, not in rationals, or we don't use fractions there.
Okay. Okay.
Yeah, so all of you have said no to this, right? And what are answer justifications you are given for all 3 questions? So essentially, why we say 3 divides 12? Because 12 now, rather than saying some situation like distribute chocolates among 3, among 4, etc. Now let's give some proper mathematical reason. So 12 I can write as 3 into some integer. Okay, 3 into some integer. What integer? 3 into 4. Right? And same equation I can also, as you look at as 12, I can write as 4 into again some integer, namely 3. But 15 you can't write. Sorry. But 12 you can't write as 5 into some integer. Is that so? So if you take table of any number, say 2, 2, 3, 4, 5, and so on. So in table of 5, nowhere you will come across number 12, right? So 5 into no integer can be 12. In fact, as somebody mentioned about fractions, 12 I can write as 5 into 12 by 5, right? And 12 by 5, that is 2.4, which is not an integer.
Yes, sir.
Is this clear to everyone? Yeah. So now we'll try to make a proper definition of this fact, like when some number divides some other number. So shall I say some number B divides number A, and what by number I mean integers, and always we divide by non-zero number. So a non-zero integer B divides integer A if I can write A as B into some integer, right? B into some Q. I write Q for quotient for some integer Q. All of you agree with the definition? So like 12 I can write as 3 into 4, right? 12 I can write as 4 into 3, and so on. So A comes in table of B, right? Or if you want to distribute A chocolates evenly among B students, you can do it without leaving any chocolate and without any quarrel. So if there is no quarrel, there is no remainder left out, then we say number divides other. Fine. So you can note down the definition and we'll go ahead. Shall I go ahead? So I'll say a very convenient notation.
Oh,
If B divides A, we denote it by the vertical line A. For example, 3 vertical line 12, and this does not mean 3 by 12 or even 12 by 3. It simply means number this side divides number this side. That's it. Is that okay? So 3 divides 12, 4 divides 12, and I want to say 5 does not divide 12, and not is usually done by slash. So for example, this is equal to and this is not equal to, right? So we give a slash for not, negation. 5 divides 12, no. 5 does not divide 12. Is the notation clear? So let's go one step further. As we saw, every number does not divide every number. So like 3 divides 12, 4 divides 12, but 5 does not divide 12, right? So what best we can do, and that is called as division algorithm. As already some of you mentioned about remainder, etc. So we'll see the most general form of divisibility. Every number may not divide every number, and what best we can do is called as division algorithm. So I'll explain with the help of example. So you tell me whether I'm saying right or wrong, or something standard or something unusual. Say 12 by 5. And I say 5 1 the 5 and 12 minus 5, 7 left. Is that standard? Is that correct? I mean, it's correct, but is it standard?
No.
Is this the way you do in schools? No. No. So I'm doing something wrong, right? Wrong in the sense, I mean, something not standard. Yeah. So let me do it this way. 5 3s are 15 and 12 minus 15. How much is 12 minus 15? That is minus 3, right? Is this correct way?
No.
No. Somebody saying no. Everyone agrees?
Yes, sir.
Yes,
Yeah.
sir.
So I'm not doing something standard, something what you can say usual. Let me try one more times. 12 divided by 5. 5 2s are 10 and 12 minus 10 2. Is this the way you do in schools?
Yes, sir.
Yes.
Yeah.
Yes, sir.
So why do you say this is yes? I mean, this is correct and the first two are wrong?
Because you should multiply the number to the closest, so it reaches the given number.
Very good. Yeah. Can you say it in little more precise words? That's fine. Answer is correct. But what do you mean by close? Kruti wants to say something.
Nearest multiple. So you divided why you should not put 15 or 5 is because 10 is the closest multiple to 12 and the number 10, the number should not be more than 12. So we use 10 we use 10 to divide 12.
But how do you decide that 10 is the closest thing?
You can decide because when you have to multiply the number closer to the given number, so then you'll be able to divide it. If you keep the number as it is, then you get a wrong answer.
Yeah. So let me put in proper words. Why, like first one is not correct or not so proper, why second is not so proper, and why 10 is closest. So I'll try to justify your answers and you tell me if that's fine, that's correct. Okay. So when I divide a number by some number, okay, whatever my quotient, I get some quotient. And this remainder which we are saying, that should be smaller than 5. Right? And in my first example, remainder was 7. 5 on the 5, remainder was 7. So it's not that close to 12. Is that fine? So the one condition is remainder must be less than the divisor. That is one condition, one rule. All of you agree?
Yes, sir.
Yeah.
And secondly, like when I divide 12 by 5, I should get some quotient and that remainder should not be negative. Can't be negative. So I should not go below 12. Right? Or in fact, rather than below 12, I should say above 12. So for example, when I divide 12 by 5, write quotient as 3. So it's 5 3s are 15 and I'm going above 12. Okay. So that my remainder is negative, minus 3. So remainder cannot be negative. This is wrong. Therefore, our remainder should be always 0 or greater than 0, less than the divisor. That is how one divides, and that process is called as division algorithm. So let me put same thing in proper words. Yes, so it should be greater than or equal to 0, right? Can I go to next page? I'll put in proper words.
Yes, sir.
Yeah, so given B not equal to 0 and A for the timing, let me assume B is positive. B integers. Assume B is positive for the timing. So we get uniquely determined quotient Q which is again integer, and remainder R. So that is some leftover. And what is condition on remainder? It should be greater than or equal to 0 and strictly less than the divisor, that is B, such that I can write A is equal to BQ plus R. And this is called as division algorithm. It's due to Euclid. Euclid was a Greek mathematician, almost in the period 200 BC, so about 200 years before Jesus Christ. And he wrote a book called as Elements, because the original language is Greek, Elements, and now English translation is available. It's in 13 parts. There are 13 books, and that contains all our school geometry and elementary number theory, like divisibility, GCD, LCM, primes, and so on. Yeah. So for example, how do we do? So algorithm always gives you step-by-step procedure how to do certain process. So like how do we divide some number by some other integer? So for example, if I divide 12 by 5, how should I do that? And you see addition, multiplication is repeated addition, and division is repeated subtraction, right? So 12 and subtract 5 minus 5, that is 7. And is that number greater than the divisor, that is 5? Yes. So we continue. 7 minus 5, that is 2. Is it greater than 5? No. So we stop. Okay, so continue your subtraction till your remainder part is not greater than the divisor. Fine. So how many times we do the process? 2 times, and that is your quotient. So 5 to the 10, 12 minus 10, that is 2. And this is smaller than this one. Is Is the idea clear?
Yes, sir.
Yes, sir.
Okay, so that is called as division algorithm. Let me tell you a funny story about divisibility, and then we'll continue further with the rules of divisibility. Yeah, so here is a story. Once 7 dwarfs, they went to meet, who was that? Snow White, right? Went to meet Snow White. What is that story? Snow White and 7 dwarfs, right?
Yes, sir.
Yes, sir.
Okay, yeah. So let's assume 7 dwarfs went to meet Snow White through some horse cart, and the cartman charged 28 rupees. So the total fare was 28 rupees. Rupees, dollar, whatever. So whatever their currency. So let's assume rupee for the timing, 28 rupees. And then they decided to share 28 rupees equally among themselves. And one of them was oldest. So he said, like this is done by division, and let's divide 28 by 7. That will give us everyone's share. So he divided it this way. It's a funny story. It's something which tells you how one should not divide. So 2 is smaller than 7, so 7 cannot divide 2. Okay, and therefore we should divide 8 by 7. So 7 ones are 7. 8 minus 7 is 1. Then you take 2 from upper side, and now it's complete division. 7 3s are 21. So he said, okay, everyone's share is the quotient 13 rupees. Then one of the dwarfs doubted this. He said, let's verify whether this is correct or not. And verification is done by multiplication. So you multiply 13 by 7. Share for each person is 13, and we are 7. So better multiply 13 by 7 and check whether the answer is 28. And he multiplied it this way. 7 3s are 21. 7 1s are 7. And 21 plus 7, 28. So he said it's fine. But again, third dwarf doubted this multiplication process also. Is that correct? Is this correct? 13 7. Is this the way we multiply?
No, sir.
No, sir.
Yeah, so there is some problem with their basics of maths. Okay. So one of the darts, the third one, who doubted both division as well as multiplication, said best and simplest thing is addition, because even multiplication is repeated addition, and better add 13 13 13 7 times. 5 6 7, and he added this way: 3 plus 3 6 plus 3 9 plus 3 12 plus 3 15 plus 3 18 plus 3 21 22 23 24 25 26 27 28. So I said it's fine. So even this answer is 28, and therefore everyone's share should be 13. And we know actually answer is actually, somebody wrote the answer 4, right? So 28 by 7 is 4. 7 4s are 28. Remainder is 0. So this is correct.
Yes, sir.
This way is wrong. Okay. Anyway, that's just a joke to explain how one should not do division, multiplication, or for that matter addition, and how one should do it. Yeah. So we have revised almost all basics. Now just coming to last part, and then we'll start with problems. So different test of divisibility. I hope you have done in schools. Test of divisibility. And let's do some simple ones. Not
Somebody is doing.
Sir,
Huh?
divisibility test of 1 is anything, right? Anything which is below, which is above, and 1 and above
Yeah, right.
will be divisible by 1.
Yeah. So everything is divisible by 1. So for 1, there is no test. Everything is divisible by 1.
For 2, it is
Test of two.
numbers ending with 0, 2, 4, 6, or 8.
Just a minute. I'll write here. If number ends with, last digit is 0, 2, 4, 6, 8. And in other words,
For third, sir, for third,
just
for
a minute.
three,
Just a
it
minute.
is the sum of all numbers.
Wait, just a minute. Let me finish this.
Sir, for test of 2, it's even numbers.
Yeah, so essentially, what are these numbers? They are all even numbers, right? Even numbers, very good.
Yes.
So if number ends with 0, 2, 4, 6, 8, or in other words, number is even, then it's divisible by 2. It is divisible by 2. So if I give you a very, very large number, so for example, 1, 2, 3, 4, 5, 6, 7, 8. And if I ask you, is this divisible by 2? You need not divide the whole thing by 2. You can just look at last digit, that is 8, that is even, and therefore its number is divisible by 2. Is that fine? So that's what it means by test of divisibility. Yeah. So coming to next number, test of 3.
Sir,
Somebody was already saying, yeah.
can I say, sir?
Yes. Who is that?
Sir.
You can tell your name also, and then you can continue with test.
Sir, my name is Adrit. So
Yes.
the test of 3 is the sum of all the numbers. If the sum of you add all the numbers, and if that number is divisible by 3, then the previous number is divisible by 3.
Okay, so let me put it a little more properly. If the sum of digits of a number, right? That's what you mean.
We can say
Yes, sir.
Is divisible by 3. Then number is divisible by
3.
3. Okay. So for example, if I say 1, 2, 3, 4, 5, 6, 7, 8, is that divisible by 3?
Yes, sir.
Yes. So what is the sum of digits? And sum we generally denote by S of that number. So S of that number is
36. 36 is divisible by 3. When you multiply 3 by 12, it is becoming 36.
36. But even for example, with 36 also, I'm not comfortable with. Even for 36, I can do the same thing. So sum is 3 plus 6, 9. And at least this is single digit. I know 3 divides 9. Okay, so I can continue till I get as simple as possible. And then if this is divisible by 3, so original number is divisible by 3. Fine? Everyone agrees up to this? So 1, 2, 3, 4, 5, 6, 7, 8 is divisible by 3. So I'll say this way: 3 divides 1, 2, 3, 4, 5, 6, 7, 8. 9 is divisible by 3. Yeah. Now what you are going to say? Test of 4.
Sir, I'm Kushal Puriya. I'd like to say the divisibility test of 4.
Yeah.
So, if there's a number and we need to see the last 2 digits of the number, and if they are divisible by 4, then the whole number is divisible by 4.
Very good. So test of 4. If last 2 digits taken as 1 2-digit number, right? So if last 2 digits of a number are divisible by 4, then is divisible by 4.
Sir, can you say for 5?
Just a minute, let's complete test of 4. So for example, let's stick to same number 1, 2, 3, 4, 5, 6, 7, 8. Is it divisible by 4? So you have to focus on last 2 digits.
It is not.
Yeah.
It is not divisible by 4.
Yeah. So we know, in fact, 4 does not divide 78. And hence 4 does not divide 1, 2, 3, 4, 5, 6, 7. But suppose, for example, if I make it say 1, 2, 3, 4, 5, 6, 7, 2 or 7, 6. Do you agree it will be divisible?
Yes, sir.
Yes, sir.
All of you agree with that?
Yes, sir.
What about 70? 1, 2, 3, 4, 5, 6, 7, 0.
No, sir.
No,
No.
sir.
It's not divisible.
So this is clear, right? Let's go to test of 5. Somebody was saying test
Sir,
of
can
5.
I say, sir?
Yes.
Sir, can I say?
Yeah.
Sir, the divisibility test of 5 is if a number ends with if the digit of the last number is 5 or 0.
Yeah. Number ends with
5 or 0.
5, then it is divisible by 5.
And sir, can you tell for 6?
Just a minute. So
Yes, sir.
for example, say 1, 2, 3, 4, 5, 6, 7, 8. Is it divisible by 5? No.
No.
But if I say 7, 8, 9, 0, is it divisible by 5?
Yes.
Yes.
Sir, can you tell the divisibility test of 6?
Yes.
Divisibility test of 6 is when if the number is divisible by 2 or 3.
Not 2 or 3. Both 2
2
and
and
3.
3, sir.
Yeah, 2 and 3.
It's not
And-
all. Yeah. So test of 6 is if number is divisible by 2 as well as 3, because 6 is 2 into 3, right? Number is divisible by 2 and 3. Please note, don't say or, it's both 2 and 3. And means it's both. Or means one of them. Fine? Then
Sir, can you tell for 7?
just a minute. Then it is divisible by 6. Okay, so in other words, it should be even. It is even means it's divisible by 2, and sum of digits is divisible by 3.
Sir, can you tell for 7?
Wait. Divisible by 3. Is that correct? So for example, 1, 2, 3, 4, 5, 6, 7, 8. Is it divisible by 6?
Yes.
So
Yes.
very first thing, it is even, and sum of
It
digits.
is. It is divisible by 6.
So yeah, so sum of digits was 36. So it was divisible by 3, and therefore 6 devices.
Sir,
Yes,
can you tell for 7?
yes, wait. So far good?
Yes, sir.
Okay. Now for 7, there is no standard test generally given in books. And
Sir, there is a
There
test.
is one test.
Sir,
Sir, we
if
have
you
to multiply the
you have
unit.
to take the last number of the
But we have to
number
multiply the
given,
unit
and then you
first
multiply.
by 2.
Then you multiply that. You add that number to the number before with
Yeah.
with the number given. That
Right.
number will, if that number is divisible by 7, then the previous number is divisible by 7.
Okay. So I remember when I was of your age, so maybe in 6, 7 standard, I found one test myself for 7, because in those days there was no internet, and in our textbook there was no test for 7. So what I did was following. I'll explain with the help of examples. Say for example, number is 105. I divided number into 2 parts. Last 2 digits as one number, and left part is one number. And I used to make double of this number, double of this, and add it to this part. So for 105, add double of 1, that is 2 to 5. And if this number is divisible by 7, then the whole number is divisible by 7. So that was my criteria. Nowadays, I see on internet there was one test famous by young boy Chika. So there is some Chika's test for a divisibility by 7.
So there is one more test, but it can be used for a 9-digit number.
Yeah, so there I used to reduce it for. So for example, you give me some 9-digit number, 1, 2, 4, 5, 6, 7, 8, 9. Okay, so I used to take this part. Okay, and I used to reduce this number modulo 7. So 12 is like 5, right? So number is like 5, 3, 4, 5, 6, 7. Okay, then again 7, 7 the 49. So 49 means this will leave remainder 4. It's like 4, 4, 5, 6, 7. Then again when I divide by 7, 7 5s are 35. 7 6 are 42. So 42 plus 2, 40. Seven 3s are 21. So this is 4. So this last 7 I can make at 0. And 46 is like 42 plus 4. So it's 47. Or I can make it 40, right? And add double of this number to 89. So 89 plus 80. And this number is not divisible by 7. Not divisible by 7. So whole number is not divisible by 7. Okay, but you can look at numbers like, for example, 1001. That's easy number, and you take double of this. That is 20. 20 plus 1, 21. That is divisible by 7. So number is divisible by 7.
So there is one more method for divisibility of 7 in 9 digit. Can I say?
Yeah. So in fact, let me tell you, someone said about mod. So using congruence, we can give various tests. So all these tests of divisibility are just consequence of congruence. Congruence in number theory. So which is shown this way. Gives test of divisibility. So there is nothing great in different test of divisibility. They are just consequences of congruence, results on congruence. Fine. Yeah. Anyway, so you
Sir,
can.
can I give the test of divisibility of 8?
Yeah, just a minute. So you can all
Yes,
check. You can all check Chica's test on internet later, not now. Yeah. So somebody said test of 8.
Yes, sir. So in the test of divisibility of 8, we need to focus on the last 3 digits of the number, and if they are divisible by 8, the whole number is divisible by 8.
Last 3 digits as one number is divisible by 8. Then the whole number is divisible by 8. So once again, let's stick to same example. 1, 2, 3, 4, 5, 6, 7. Is it divisible by 8? You have to focus on 678, and you see 8 does not divide that. So this is not divisible.
Sir, I have a question. What if the number itself is a 3-digit or 2-digit number?
So in that case, you have to actually divide that number and decide. So anyway, when it's up to 3 digits, it's easy to work or easy to handle. But if your number is too big, like say 10 digits, 12 digits, and so on, that could be difficult. And in those days, when these tests were developed, there were no calculators, no machines for checking. And so they were important in those days. Now with calculators and computers, they are not so relevant. Because you can check the whole number divided by 8.
Sir, can I tell the divisibility test for 9?
Yes.
Sir, for 9, you have to, I don't know.
For 9, you have to to see if all the sum of the digits is in the number is 9.
Yeah, very good. So if sum of digits is divisible by 9, it's just tastes like 3. And when you learn congruence, you will know why the test of 9 and test of 3 is essentially same. If the sum of digits is divisible by 9, then number is divisible by 9. Okay, and say for example, let's stick to same number 1, 2, 3, 4, 5, 6, 7, 8. So what is the sum? Sum is 36 because this we have done earlier, and 36 is divisible by 9. Divisible by 9. So 9 divides 1, 2, 3, 4, 5, 6, 7. Is that okay? And which means even if you change the positions, if you permute the digits, still it's divisible by 9. So for example, if instead of this somebody takes 5, 6, 7, 8, 1, 2, 3, 4, that's also divisible by 9. Yeah. What is test of 10? Obviously, it ends with
So
0.
if the number ends with 0, then it is divisible by 10. So can I see the test of divisibility of 11?
Yeah, and that will be our last test because after 11 we won't work. Okay. So then we'll shift to problem section. Number ends with 0. Then it is divisible by 10. Yeah, somebody was saying test of 11.
Yes, sir. So in the test of 11, we need to add all the alternate digits starting with the ones unit, and the sum should be divisible by 11. Then only the whole number will be divisible by 11.
Yeah, or let me explain with the help of examples. Example, say 354. Is it divisible? No. 341. So you add alternate digits. So like after 1, 3. Now this is only 3-digit number. So we have to add only those two numbers. So if this sum and so sum of even place and sum of odd place, if they are equal or the difference is divisible by 11. So in this case, they are equal. 3 plus 1 is 4. Right? And therefore is divisible by 11. But let's check our number. 1, 2, 3, 4, 5, 6, 7, 8. So what we have to check is following. 1 plus 3, 4 plus 5, 9. 9 plus 7. That is 16. And let's check all odd place digits. First digit 8 plus 6, 14 plus 4, 18. 18 plus 2, 20. And this difference is 4. It's not multiple of 11. It's not multiple of 11. So number is not divisible by 11. Is the test clear?
Yes, sir.
Yeah. So we'll shift to now the problem section. Based on what we have
No
learned.
divisibility rule for test of 7 of 9 digit. I have one more.
Yes.
Sir, we can divide that 9-digit number into 3 parts, each of 3 numbers. Like if I take the number 774,552,94, then we will divide it into parts like
77455.
552,94. Sir, we will make it into into parts. In each of means we will divide it into 3 parts. In 3 pairs. So we will take 7 as one part,
Okay.
4 4 5 as second part, and 2 9 4 as third part. Then we will add the first part, which is 77, with 294. So we
Very good.
371, and then we will subtract it from 455. So 455 minus 371 is equals to 84, and 84 is divisible by 7.
Very good. Yeah. So that will work. In fact, one can check by congruence that this works for modulo 7. Good. So far fine, everyone? Any queries, any doubts?
No, sir.
Okay. So we'll go to problem section. Nine divides, can you read, or is it smaller? If 9 divides 36A, where A is some digit, 36A958, then A is equal. You can put answers in chat box, but only to me, not to everyone. Yeah, everyone has written correct. Yeah, good. So most of you have written answer as 5. A should be 5. Let's discuss why answer is 5. So 9 divides, shall I use this notation? 9 divides 36A958 means 9 divides the sum. 9 divides the sum of digits. And what is sum of digits? 3 plus 6 plus A we don't know.
So 31.
So plus 9 plus 5 plus 8, and this turns out to be 31 plus A. Now if I take A as 1, for example, then the sum will be 32. If I take A as 2, then sum will be 33. If I take A as 3, sum will be 34. If I take A as 4, sum will be 35. If I take A as 5, sum will be 36. And we know 9 divides 36.
Future idea so much.
So A must be 5, right?
Yes, sir.
Everyone agrees?
Yes, sir.
Shall we go ahead? So A is 5, answer is 5. If 11 divides 2AB9, then what is B minus A? So 11 divides 2, AB 9, AB are digits, means 11 divides, say, A plus 9 minus B plus 2, right? Alternately, A and 9 and B and 2. So 11 divides the difference, which means 11 divides A minus B plus 7.
Sir, can you see the answer?
I'm not sure the answer from chat box.
Sir,
Now,
can you see the answer?
who is that?
Can you see the answer?
Yes, yes. Who is that? You tell me your name.
Adrit. Adrit.
Oh, yeah, okay.
And A is equal to 2 and B is equal to 9.
Is that the only
A,
answer?
A and B should sum up to 11. So it can be anything which sums up to 11.
No. Why A and B add up to 11?
Because the rest of the numbers are 2 and 9
Huh?
equals 11.
But for 11, the test is alternate sums should be either equal or divisible by divisible by 11.
So I think the correct answer would be 4. The difference of A and B.
So A minus B plus 7. Now A minus B can't be too big because they are digits. So the difference will be maximum 9. So A minus B, if I take it as 4, then 4 plus 7 is 11, and 11 will divide that. Okay. So which means we are asked what is B minus A. So if A minus B is 4, B minus A must be, shall I say minus 4? Is that fine? Minus 4. Or if A minus B is minus 7, then minus 7 plus 7. Difference will be 0, or I mean sum is 0, and 11 divides that, right? So B minus A should be 7. And you take any two such digits whose difference is either minus 4 or 7. Yes? Is someone asking something? I can't understand. Hello? Is someone asking something? Okay, yeah. So B minus A should be minus 4 or plus 7. Okay, now let's try various examples. So suppose if I take A and B to be, say if I take A as 0 and B as 7, B minus A would be 7. And you can verify that 2079 is divisible by 11. You can check that. Right? So that is perfectly divisible. So if A is 0, B is 7, number is divisible by 11, right? Or if I make A as 1, B should be 8. So again, difference is 7, and you can check. So now I leave it to you. You check whether this is divisible by 11. Is it divisible by 11?
No, sir.
Huh?
Yes, it is.
Yeah. Or maybe I can make A as 2, B as 9. And still the difference is 7. So you can check again 2, 2, 9, 7. Whether it is divisible by 11. Oh, sorry, 9, 9. Yes, so 2, 2, 9, 9 is obviously divisible by 11.
Sir,
Yes.
so can you explain like in the first, like what did you did again? 11 divides that.
Yes, yes. Let's see once again. You look at alternate digits and the difference of these additions. So B plus 2 and A plus 9. The difference, anyways, this minus this or this minus this, anyways. The difference should be divisible by 11. So I have to
Okay.
put it this way, A plus 9 minus B plus 2. And that means 11 divides. So 11 divides A plus 9 minus B plus 7. You can take it other way, no problem. You get same thing. 11 divides A minus B plus 9 minus 7. Oh, sorry, this is 2. 9 minus 2 is 7.
Yes, sir.
So 11 should divide A minus B plus 7, right?
Yes.
And which means A minus B should be minus 7 or B minus A should be 7. So that the difference is 0 and every number divides 0.
Okay, sir. I understood.
So we have found various cases of A and B where difference is 7. And that gives
Yes,
us
sir.
3 answers. 3 answers.
Yes, sir. I understood.
As well as we get B minus A as minus 4. So let's try with B minus A as minus 4. Or A minus B as 4, right? If A minus B is 4, B minus A is minus 4. So I can take this as 4, this as 0. Take this as 5, this as 1. And take this as 6, this as 2. And with all these cases, you can check whether number is divisible by 11. Eight, 4, 9, 5, and that's it. Next, after 9, the number is 10, and it's not a digit. It's a 2-digit number, right?
Yes, sir.
Yeah, so you can check any of these. So for example, 2409 divided by 11. 11 2s are 22. 11 1s are 11. 11 9s are 19. So that's a complete division, right? Or you can check 2519. So 2409, 2519, 2629, 2739, 2849, 2959. And these are all divisible by 11.
Sir, the correct answer is 4 or 7.
So what is the answer? B minus A should be either 7 or minus 4.
Okay, sir.
And again, you can see one fact, the difference between 7 and minus 4 is 11, right? Difference between 7 and minus 4 is 11. 7 minus minus 4, that is 11.
Yes, sir.
Can we go ahead?
Yes, sir.
So let's do one RMO problem. It's little difficult. And with that, we'll stop then for today. But the PDF contains further some 10, 11 problems. So you can try other problems as homework. Okay. And it's fine even if you don't get those problems, but keep thinking. That's more important for Olympiads. Yeah. So this is RMO 1993 problem. So as I said last time, earlier there used to be PRMO, RMO, and instead of that, now after Corona, they have started what is called as IOQM. So this was a descriptive exam, 6 questions and 3 hours. Yeah. In a group of 10 students, each student is asked to write the sum of ages of all other 9 students. If all 10 sums form a 9-element set, 82, 83, 84, 85, 87, 89, 90, 91, 92. Find ages of all students. And all ages are whole numbers. So nothing like 15 years and 6 months or something. So all are whole numbers, like 11 years, 5 years, 12 years, and so on. Yeah, so first of all, do you see, is there something wrong? There are 10 students, each will answer the sum, and therefore there should be 10 answers. But those 10 answers form 9-element set. What it means? So this is something tricky. Is it something wrong? Or if not wrong, what it means?
Sir, there are only 9 answers.
So 10 students will be giving 10 answers, right? But essentially set contains 9 numbers.
Sir, are 2 answers same?
Very good. So it means 2 answers are same, right? Very good. So very first observation, 2 answers must be same. Which means 2 of them must have same ages, right? So let's say, suppose we have 10 students. Student number 1, not good at drawing. Student number 2.
Sir, they all have to be, the ages have to be consecutive numbers.
Yeah, very good. That's another observation, because your numbers are like 82, 83, 84, and so on.
Sir, what is the element?
Element is member of the set. So there are 9 numbers or 9 members in the answer set.
Okay.
For example, if I say set of students in a class, then student is element of that set.
Okay, sir.
So I have drawn 10 students. And let's say suppose age of first student. Right now we don't know anything about that. So shall I call it say A1, age 1, age 2, age 3, age 4, age 5, age 6, age 7, age 8, age 9, age 10. Now, first student, what he'll answer? The sum of ages of second to 10th person, right? So let's say, suppose A1 answers S1, or I mean, first student answers S1. What should be S1? Are the notations clear?
A2 plus A3 plus A4 plus A5 plus A6 plus A7 plus A8 plus A9 plus A10.
Very good. So S1 will be what? S1 is answer given by first student. So sum of other 9 students. So it's A2 plus A3 plus A4 plus A5 plus A6 plus A7 plus A8 plus A9 plus A10. Good. Everyone is following notation? So somebody tell me now what should be S2? Sum given by second student.
So can I say,
Sir, can I say?
Yes.
Sir, it will be.
sir, A1
Hmm.
plus A2, sorry, A3 plus A3 plus
Yeah, very good.
A4
Yes.
and so on, sir.
Shall I say dot 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 up to A10? Is the notation clear? Mathematicians are
Or it
late
can also be.
writing, so they write dot dot dot.
Sir, it can also be like S2 is equal to S1 minus A2 plus A1.
Very good. Also, S1 minus A2 plus A.
Plus
Very good.
A1.
So you remove A2 and add up A1, right? And so on. So I'm just saying and so on. Up to S10. What will be S10?
So S10 will be A1 plus A2 plus A3 plus A4 plus A5 plus A6 and so on till A9.
A1, A2, A3 up to
A9, sir.
A9. There won't be A10, right? Everyone agrees? So each person, each student says the sum of ages of all others, right? And one of these numbers, 82, 83, 84, is repeated, right? Two answers must be same, right? So suppose,
Excuse me, sir.
yes,
Sir, S10 is also S9 minus A10 plus A9.
very good, yes, yes. So suppose one of those numbers which is repeated, we call it as X. Suppose repeated number is X. I don't know right now which number it is. It will be out of 82, 83, 84, 85, 87 up to 92. Fine. Suppose repeated number is x. Okay. So with that, there will be 10 numbers. Fine. And these 10 numbers, do we agree will be S1, S2, S10? So set S1, S2, S3 up to S10 is same as 82, 83, 84, 85, 87, 89, 90, 91, 92 and x. And x will be what? Some number out of 82 to 92, right? So far good. Shall I go to next page?
Yes, sir.
Now what we'll do is add all these numbers. Fine. That gives us something. So S1 plus S2 plus S3 plus S4 plus S5 plus S6 plus S7 plus S8 plus S9 plus S10 is equal to. Somebody quickly tell me this sum of all these numbers. Something plus x. How much is that? Is it 871? No.
784, sir.
783.
83.
Okay. So it is 783 plus x. There is one x there. Right? And now I want to simplify this in terms of ages of students. So see
Sir,
that,
can I say?
yes,
Sir, it will come as 783 is equals to age of all students into 9. So we will divide 783 by 9. So we will get the sum of ages of all students.
yeah, very good. So Agam is saying, when we add all these 10 numbers or these 10 sums, every age occurs 9 times. All of you agree?
Sir, I found the ages.
Just a minute. Huh? So we'll get every age A1. A1 will be told by or counted by second person, third person, fourth person, up to 10%, right? Only first person won't count A1. So A1 gets counted 9 times. A2 will get counted 9 times. A3 gets counted 9 times. A4 gets counted 9 times. A5, A6, every age gets counted 9 times. All of you agree? Any doubt with this?
Sir, I found the ages.
Just a minute. So
I found,
shall I say 9 times of this is 783 plus x, right?
sir, can you tell the ages?
Wait.
Sir, we will divide then 783 by 9 and we will get 87.
Yeah, but now we have something related to divisibility by 9. So that's why, in fact, I took this problem for discussion. So 9 times of something is 783 plus x. So shall I say 9 divides 783 plus x? Okay,
Sir, can I tell?
wait. I'll explain.
Sir, x should be divisible by 9.
But now you see 9 divides 783. That you can check by test of divisibility by 9. So 9 must divide x, right? So 9 should divide x. Okay. And what is x? X is repeated number. So it's out of those numbers. So you find out number which is divisible by 9 out of this.
90.
And that is 90. Okay. So x must be 90. All of you agree?
Yes, sir.
Can explain why x will be 90?
Yeah, I'll explain once again. So 9 divides x. Is that clear? 9 divides 783 plus x.
Yes, sir.
And out of which 9 divides 783. So 9 must divide x, right? So x is divisible by 9 and x is out of these numbers. Sorry. X is out of these numbers. One of these numbers is repeated and we are calling that as x. So which number is divisible by 9 out of this?
90.
9. So x must be 9, right? Okay, so x is 90. Is that fine?
Yes, sir.
So now can you see the ages?
Yes. And now I know which number is repeated. So I know now we can find out all ages. So this sum is basically what? Just a minute. So A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus A7 plus A8 plus A9 plus A10 is 783 plus 90, and I'll take this 9 for division. So I'll take 9 to right side. We'll go for division. Everyone agrees? And this is what? 9 8s are 72, 9 7s are 63, plus 9 10s are 90. So this is 97. So sum of all 10 edges is 97. Okay. But when I say S1 contains numbers A2 to A10. And suppose that is first number. What is our first number? 82. So A1 plus 82. Shall I write here itself? So A1 plus 82 is 97. Which means I can get A1, that is 50. Similarly, A2 plus remaining numbers, and that is how much? That is 83, right? Answer told by second person, that is 83. So A2 plus remaining numbers, that is H2 is 83. This is 97. So that means age of second student is 40. And so on. You can find ages of all of them. So I leave it to you to find ages of all of them. Okay, as well as in this PDF, there are some more questions. You can try them later.
Sir, I got the ages of all the students.
Yeah, very good. And you see one number is repeated, right? Yeah, so you see there are 10 questions here in this PDF. It's time. Shall we stop now?
Yes, sir.
Tomorrow we'll have discussion on prime numbers and properties of primes. Fine.
Okay, sir.
I hope you are all following and enjoying these things.
Yes, sir. Yes, sir.
So bye for today.
Bye, sir.
Thank
Bye,
you,
sir.
sir.
Bye, sir.
Thank you, sir. Bye, sir.
Bye, sir.
Bye.
Bye, sir. Thank you.